Alright, sweet. We're live, hopefully. If we're not live, then oh well. So this is just a brief overview and introduction into JavaScript. It's going to start out really simple, so bear with me. This kind of assumes that you have some exposure to code, but really not much at all. So it's a C syntax language, and that means that we'll get some automatic similarities. One of the ones is comments are 2 forward slashes, and you can do comment blocks with a forward slash and a star. So anything that's a comment or in a block comment will not be read as code. You can put that throughout your document however you want it. I mean, obviously the more you add, the bigger it gets, so don't bore us, but obviously you want to make sure that anything that's really critical, that does weird things, that isn't obvious, should be in some way documented. Some of the symbols you'll see in JavaScript are parentheses. Again, this is C language, so it's very similar to like C++, C#, things like that. Parentheses are used to group math evaluations, things like, order of operations, right? So if you have 7 plus 5 times 4, if you don't specify in parentheses, you want to do 7 plus 5 first, then it'll do 7 plus 5 times 4. So you can group it in parentheses. Similarly, if statements, you'll see, loops, things like that, will have in parentheses and then some sort of expression. And things like functions, you group your parameters inside those parentheses. So you see those all over the place. And curly braces are another thing that will be all over code. They define scope and also objects, and the way they define objects kind of relates to scope. Anything that happens inside parentheses, kind of like Vegas, right? Anything that happens in parentheses hopefully stays there.
Including variables?
Including variables that are declared inside of the parentheses. But if you define a variable outside of the parentheses, right, and then you do stuff to it in Vegas, quote unquote, in the braces, then that will persist. So it's kind of like if you go to Vegas and you have a wife already, whatever you do with your wife does happen.
Yes.
But if you go to Vegas and you get married, then none of it counts later on when you leave Vegas. This metaphor is stretched very thin. So that's braces. Brackets indicate arrays pretty much exclusively. So anytime you see brackets, you're either declaring an array or you're using an array. JavaScript is a zero-based array system, so, oops. It starts at 0.
Yeah.
Yep. Gosh, I'm on a Macintosh and I'm not familiar with Macintosh so you'll have to excuse my occasional typos. But so it starts at position 0, then it goes 1, then it goes 2, then it goes 3, whatever. You can get the length of an array using the .length function. Nice, simple, no problem. Semicolons and statements, they aren't necessarily required, but please use them. They keep the language neat. It's easy to see where things end. Some systems, like we're using Titanium in-house, will mark a missing semicolon as a warning, but it is allowed. Just don't do it. It's bad. It's a bad no-no. All right. Equal signs are a little tricky because there's 2 versions of the equal sign. We're looking at a single equal sign that always denotes assignment in JavaScript. In things like SQL, equals could be either way. It could be assignment or it could be a test. In JavaScript, anytime you see equals, single equals, you're always assigning to something else. There's some shortcuts to some of the things we'll be doing. So I mentioned, you can do addition. Obviously, it's a programming language. If you couldn't do addition, we'd be in trouble. But there are shortcuts that kind of carry over from C++, and one of them is the plus equals operator. So instead of doing x equals x plus 5, right, which would add 5 to x, you can just do x plus equals 5 or x plus equals 6. And similarly, you can do x minus equals and x times equals and so on. And if you really want to shortcut, anytime you want to just add 1, you can do plus plus. So if we start out with x equal to 1, and then we x plus plus, x is now equal to 1. Or sorry, equal to 2. Haha, I can't even, there we go. X is now equal to 2. Nice and simple. You don't need to use those. Those are just shortcuts, and you will probably see them sprinkled throughout code because they're very popular.
Now you can also have the pluses beforehand.
Yes, you can. That's
With
much
different
less
results.
popular. The reason is x++ increments after usage, plus plus x increments and then uses it. So that doesn't necessarily matter if all you're doing is incrementing the variable, but if you have it as part of a while loop or a for loop, an int loop, while loop, for loop, whatever loop, if you're plus+ing first, then you will always be one ahead. So I just use,
X plus plus.
but yes, that does exist. Comparisons. So these are basically instead of doing assignments here, so we've got the single equals. This is a double equals. Double equals is always an evaluation. That's you're testing if something is equal to something else. Anytime you see a exclamation mark, that is a not. That means not this. So not, and then equals is obviously not equals. That tests to see if the two things aren't equal. If you've got a 5 and a 6, obviously they won't match. There's a little bit of a thing we'll go over in a later demonstration where there's a triple equals, and because JavaScript's casting system is a little loosey-goosey, this can end up in pitfalls, but for now we're dealing with concrete stuff.
It's like a very strict evaluation.
Exactly, yep. All right. So, less than and greater than work exactly like you learned probably in grade school or wherever. Less than checks to see if something is less than the other thing, and greater than is the opposite of less than. There are inclusive versions, which is the less than sign and the equals, and a greater than sign and an equals, and that just means it can be less than or equal to. That's pretty self-explanatory.
And you did not use any one of those as well. The not.
Yes.
Not less than.
You can.
Not greater than. All right.
But usually you just use the inverse. So.
Use the less than instead of the greater than, and greater than instead of the less than.
Double ampersand and double pipe are logic operators, but roughly what they equate to is if you have a double ampersand, that means both sides of it have to be true for the whole statement to be true. So if I have a car and my car is on fire, I want to call the fire department. I guess actually that's an or, because if my car is always on fire. Anyway, but you see what I mean. If both conditions are met, then whatever happens. The or means that either one of the things could be true, and the whole thing will count as true. So maybe if Johnny likes red balloons or blue balloons, and you give him a balloon that's red or blue, then he'll be happy.
Double and.
Yep. If they're both false, then this equates to false. So that's just really an intro to logic operators and.
Is single ampersand ever used?
You know what? I don't know. I don't think so. Usually it would reference an address in like C, C++, things like that. It would be referencing an address of a variable.
There's no single one.
Off the top of my head, no. There's probably something about it.
And the same thing with the pipe. So only single pipe, no single pipe.
No, I don't use. No, I don't even know what it would be for.
Okay.
I don't think you could single pipe it.
Okay.
So JavaScript's a non-compiled language. So now we're past like the weird, complicated stuff. JavaScript's non-compiled. That means it's interpreted on the fly. That makes it really, really handy as a learner, like a beginning language, because you don't have to have any kind of specialty software to use it. It's also the most popular language in the world, because every single browser these days runs JavaScript. So you could say Java is installed on X number of computers. Well, guess what? I bet every single one of those computers also runs JavaScript. C++ runs on my mainframe. Well, does your mainframe have a crappy version of IE? Then JavaScript is on your mainframe. So you will find JavaScript on just about every consumer, device out there, like computers at least. I mean, obviously your fridge probably doesn't run JavaScript. Everything in JavaScript is considered to be an object. So that includes functions. Functions and objects have a weird relationship in JavaScript. It's not a standard object-oriented language. It does have object-oriented factors, but it's a prototype language, and I will get into that in a far-flung, distant future tutorial. But for now, let's just assume everything's an object, including functions, including numbers, including pretty much everything in the thing. There are two types of objects. There are reference types and value types. A value type, in this case, is a Boolean, a number, or a string. And the easiest way to even show you how value types work is down here we've got some simple assignments, right? So we start out with x equal to 5.
Yeah.
Then we say y is equal to x,
Yeah.
which makes y equal to 5.
Mm-hmm.
Then you set y equal to 6.
Mm-hmm.
Now, in a value type, each time you assign to y, it only assigns to y. It doesn't affect x. It doesn't follow this chain back up. It doesn't say, hey, y is also x, and x was 5, and what do we do with that? You're just straight up dealing with a new object.
Yeah.
So because it's a primitive, it's a value type.
Mm-hmm.
Every time you're modifying it, you're modifying just that object, no other previous objects in the chain.
Mm-hmm.
Reference types work a little differently, and these are the types that you will most likely encounter, like on your day-to-day work and experience in using JavaScript. You'll use lots of reference types. You'll see here I declared an object. This is a more complicated object. I use braces as the declaration structure. And this is JSON, which is a stripped down way to declare objects in JavaScript. It stands for JavaScript Object Notation. And effectively it works with a key and a value. So you say the value property is 5. You could say, I don't know, you can say anything really. So you could say, let's say the railroad value is equal to $200.
Do you do equal or the
Oh, sorry, colon. Yep,
yeah.
sorry.
Now, what's the difference between that and the one up top? I know you said they're all objects. So why is this object different?
Because it's not a primitive.
Okay, now you're saying
primitive
from
is
a value one to a reference one. Got
exactly. So we've moved from value to reference because we've gotten a little bit more complicated.
Gotcha.
So value is like a string. So you might also be up here, test.
Mm-hmm.
That's also a value.
Got it.
As soon as you put in properties, then all of a sudden we've got reference types. And reference types are treated slightly differently in that anytime you assign a reference type to a different variable, for example, down here we declare x and we set it equal to value 5, railroad $200. I guess we're playing Monopoly, I don't know. Then we assign y equal to x, and then we change y's value. This changes x's value as well. Y, in effect, has just become a reference to x. This happens a lot when you're dealing with functions. You'll be passing things around. You'll be like, hey, take this object and do something with it. You know, like maybe you're playing Monopoly and you want to mortgage the railroad, right? So you'll say, hey, banker, mortgage this, and you'll pass them that object. When you pass them that object, whatever they do to that object affects your original object.
Gotcha. Yeah.
Because it references the original
Because it
object.
references
Point in memory.
Right.
Yeah, it is a point of memory,
yeah.
but that's a bit more advanced than I really want to get into at the moment. Let's just say that it's as if
Same thing. Yeah. Okay.
yeah. So those are the two different types of variables.
And once you use a create a variable like that, the reference type one, and you're referencing y, you have to specify, or x, you have to specify which variable inside of
Which property,
Which
yes.
property, they're called properties.
So you could have
Yes.
said y dot railroad equals $500.
And you could just say
Yep.
y equals. I mean, you can't just go pull out y.
You could,
You
if
get-
for
you get
example,
everything?
yeah. So you could, for example, just
Gotcha.
modify. You could create a brand new object. You could say now y is equal to a blank object,
Clears it out.
and all of a sudden x is equal to a blank object. Yep. So whatever you do inside there, as I said, so JavaScript is extremely loosey-goosey. And what you could also do is you can invent properties on the fly, and it doesn't care. So you'll notice in my original x
You didn't have
object,
one, yeah.
I don't have, for example, mortgaged. Right? Now all of a sudden, it's well, let's set it true. So now all of a sudden, I didn't even have the concept of a mortgage to start with, but now, boom,
Just
my
create
railroad is
new
mortgaged.
properties are created.
Yeah. So
That's cool.
that's
I
a
like that.
really cool function, not function, but ability of JavaScript. It's extremely loose, and it'll let you basically do whatever you want with it.
Yeah, and the bad thing about that is if you sprinkle that throughout your code, then you don't really know
Pretty
what the
soon
properties
you're
of
not-
X are because
right.
they're everywhere.
Is there
Right.
any way of
So
putting
you're
a
better
list
off
of
to
them?
declare them at the
Yes,
where X
you can
is.
pull a list of all of the internal parameters or properties, I should say,
Yeah.
of an object. We're not going to do that right here,
Okay.
but it's kind of like reflection. But yes,
cool.
you can view. You can not only view them, but you can also change them and you can rename them. And
Awesome.
so.
I like that.
All right. So we've seen just the two types of things, but let's actually talk about declaration. Whenever we're declaring variables, we use the var keyword.
And I call it var.
Var. Sorry.
Var.
I don't. Variable, variant.
So you'll hear var, var, either one.
Yeah. But that's very important to remember. I constantly get tripped up when I switch from C# to this or whatever else I'm programming in, because they usually want int x or string y or whatever. Yeah. So it's just var x all over the place. You can also so here's one of the examples of variable declaration. We declare a variable and then we use it later on. We set it equal to 6.
Mm-hmm.
If you haven't used this variable, just saying var x, that starts it out as null. That's the same as saying var x equals null.
So once you set it to 6, it knows that var is an int.
Yes.
If you set it to
a
quotes,
string, yes.
my name or Lori, then it knows it's a string.
Yes, and you can get that information out. There's like tests you can do. Mm-hmm. That's in a distant one again, because that can be a little complicated.
Okay.
But yes, it can be anything you want, and you can change it on the fly. It doesn't really care. Mm-hmm. Usually you'll see it like this. Usually you'll see the variable declared and assigned in a single thing, and that's because most of the time we want to know, name is equal to something. Yeah, there we go. So you usually want to start out with some kind of value as a default, but you don't have to. It doesn't make you, but that's a very common thing to see. These are the examples of the variables. Oh, actually, I'm glad I put this in here because I would have forgotten. It is possible to use variables that do not exist yet. So if you just wanted to start using y, you could do that. It will allow you to do that. The catch is this puts them in a crazy scope that's like global, and it can cause all kinds of problems. Basically, just don't do this to start with. Try to only use assigned to variables you've already created. Otherwise, you're setting yourself up for disaster in the future. We can go over scope and all that stuff in a future tutorial. But so do this, don't do this. This is bad. No. All right. So here are just some simple examples of objects. We have the integer declaration. You can also do like decimals or floats, whatever you want to. You could say var x equals 1.6 or whatever you want to do there. Mm-hmm. You've got strings, which are in quotation marks. You can also use single quotation marks. That is also allowed. If you are working with quotes inside of quotes, that helps a lot. Like, so if you want to have someone said something like, Steve said, no, don't throw that. See, I'm already hit with those.
You have to escape.
Throw that volleyball at me. Oops. So you can put double quotes inside of single quotes or single quotes inside of double quotes. If you need to use a double quote or a single quote inside of another thing, put a backslash in front. It's a standard escape character. You'll see that all over C, C++, C#, whatever. It's usually a backslash. Boolean values, which are true or false.
But you never close that first. You never close the second quote, right? But I guess that's matter.
I did right
No,
now.
it's closed, yeah.
The second one? The
Yep.
middle one? The double quote?
Oh, yeah, you're
The
right. I'm
double
sorry.
quote, yeah.
I'm ruining everything.
Okay, just checking. It didn't catch us an error though, huh?
No, because it's...
We're not doing anything
This
yet.
is just inside of... This is a...
Just a
This is just a string.
A comment, a string, yeah, exactly. It's
Yeah,
a
so it
string
doesn't
inside
really
of-
care.
yeah,
I could
gotcha,
just...
gotcha.
I could
Got it.
just be like... Brrr.
It's just a string.
Yeah.
Got it.
Booleans are only trues and falses.
Mm-hmm.
In general, there are equations, like, you can equate certain things to a Boolean, and I'll show you how to do that later on, where effectively anything that isn't, I think it's null, 0, or undefined will be true. So if you have a string equal to the word 1, If you test it as part of a Boolean, 1 will be true, 2 will be true, 3 will be true. The word swordfish would be true. Anything like that will
the fact that it exists.
Yes. Yep. Arrays. There's 2 ways to do arrays in JavaScript. There's the literal array declaration here, which is just r equals, whatever your array name equals, and then open close brackets. That is the preferable one. You can also use the new array function. I wouldn't recommend doing that. It's uglier, it's a little bit older, and it's a little bit slower. It's just not as nice. Just, no. And then objects, you can also do the same thing. So we have a literal object declaration, which is in JSON. And you saw that earlier up there. You indicate you're starting JSON with a brace, and you close the brace, and then everything in between is a type, like the name of the parameter, or the name of the property, then a colon, and then whatever the value is. And you can have tons and tons of these. How about dog, some dog, cat, Mr. Meow. So you can just keep doing that. The other way to do that is you can, again, use new object, and then you can manually declare those properties on the fly. It's a little clumsy. It's a clumsy way to do it.
Older way,
yeah. Later on, I'll show you how to write constructors using functions. But again, that's not really for this thing. But that's a really good way to do objects if you're going to be creating a lot of them that are the same. But basically, this is what you'll see all over the place is equals and then some braces and properties. I already showed you this, but we'll show you again. You can do dot any made-up parameter you want, and all of a sudden, blam, it exists. So here's a very simple object with 2 properties. You'll see I happen to like spacing them.
I like that.
Like that. Like I put a carriage return line feed or the enter button between properties. It makes things a little bit easier. So we've got a balloon here. It's red and it isn't popped. So functions. Let's talk about functions. Are like anytime you want to do something interesting, you probably want to put in a function. It's a discrete chunk of code that will serve a very specific purpose. You don't want your functions to get too crazy. You usually want a short to the punch result. You can put functions inside of functions. You can make calls to other functions. But functions are in general all over the place in, not only JavaScript, but other languages as well. So let's take a look at this. Here we go. You can modify your variables, or you could, for example, check to see if a variable has some kind of property. In this one, I'm just checking to see if my toast is done. I like my toast burnt. So the toast check function is declared as a variable, var toast check equals function, and inside the function I take a parameter. That parameter is the thing that I'm doing stuff to. You don't have to have a parameter inside of a function, but it's usually advised. You can, for example, declare a variable up here, my toast.
Something.
Yep. And then use it inside of functions that share the same scope and blah, blah, blah. Don't worry about scope at the moment. We want to focus on passing objects because that's one of the best ways to do it. You don't want to use global variables all over the place. That way lies madness. You want to have something you're going to do, and you want to have something you're going to do it to, and you want to combine them, and blam, you get a result. So again, this one's really boring. It just checks to see if my toast is burnt. If it is burnt, it returns true. If it's not burnt, it returns false. The return keyword means you can get a value back for toast check. And actually, this is a secondary way of declaring it. So, if I was going to say, you could say var how is my toast doing? And then you could say toast check my toast. And depending on whether it was burnt or not, this variable would become either true or false.
Yeah, see, that's the way I'm used to doing it. So I got to get familiar with that way up there.
So the first function you wrote,
Yes.
if my toast, which you passed in from the parameter,
Yes.
dot smell. Are you creating a new?
This is assuming that a property exists. And that's a good
Okay.
question. So, if smell the dot smell doesn't exist, then we got a problem, right? You could have a null ref. Maybe I passed in the a null instead of my toast, right? So in general,
So my toast would have a smell property.
yes,
Got it.
absolutely. So in this case, it might look like this: smell burnt.
Right. Gotcha. Okay.
But if it doesn't have a burnt property, we're in a pickle.
Yeah.
So usually, you'll see people do things like, if my toast and my toast dot smell and my toast dot smell is equal to burnt. So that says, did you actually give me something, or do I just have a null?
Now that'll assume it's null, not true, right? It's looking to see if it's null, or if it's looking to see if it's not null, rather.
Right.
Okay.
So all it knows after to get past this first first check, all it has to do is exist. Then it automatically.
Gotcha.
I guess I should say this. So, if statements are evaluated left to right, and the way it works is if you got an and it fails the first one, it already knows the rest of the sentence doesn't matter. The rest of the comparison doesn't matter. It's definitely false because all of those things have to be true in order to be true. So it will automatically just end. It'll end the if statement here. It'll be like, nope, I don't have my toast. So then we check my toast.smell. Does my toast.smell exist? This might not be necessary because if you don't have this parameter, it'll just be null. And if you're comparing null to the word burnt, it's not going to be true.
It'll fail, yeah.
So
So
you don't.
So an if without any equals or any evaluating the double equals automatically is asking if it exists.
Yep. So let's say we've got var x.
Yeah.
If you say if x, because
If
x is null, this will fail. It will.
Ooh, even though it does exist.
The variable exists, but there is
No-
nothing
no
assigned
value
to it.
assigned,
It is
yeah.
null. It is empty. It is
Gotcha.
meaningless. So it
So if
has
you had
nothing.
var x equals, in quotes, ed, and you said if x,
That would be true.
Then it would be true.
Yeah.
Yep. You could also say if var x equals null, that will be false because null evaluates to false.
Yeah.
You could say false,
Yeah.
or you could say 0, and that will also
false.
be false. But if you go 1, that's true. Any words, even this, will evaluate to true.
Yeah.
Because it exists.
Yep, absolutely.
I like
Okay.
the and stuff because normally you have to do if or else, if else, if else, if else. You know.
Right,
Yep.
you could do it all in
Just
one
do it
line.
in
then,
one
yeah.
line.
Yep. So we're not going to use the mytoast.smell because that's not really important. There we go. So if my toast and the property of smell on my toast is equal to burnt, then we return true.
Awesome. Yeah.
There are other ways to declare functions. In particular, this is a function declaration, and this is a function expression. It's very important to note
like
that they behave slightly differently.
Interesting.
This is the standard way to that most of the time you will be doing things. So that's, if you have to memorize a way to do it, memorize this one. Effectively what we're doing is we're creating a new object and we're setting it equal to the function. You remember how I said everything's objects? Even functions are objects. It's a very, you just have to, once you get your mind around it, it kind of makes sense. But so toast check is now equal to the function of that. If you use function declaration, you get some unusual side effects. They're not necessarily bad side effects if you mean for them to happen, right? They can be effects, I guess, rather than side effects. But if you don't expect them, then you can have problems. One of the side
What do you mean
effects.
by don't expect them? Yeah.
So hoisting, for example, is something that's kind of unusual about function declarations. When you declare when you use function declaration, it will move that to the top of the scope that you're in, even if it's used. It's declared after it's used. So here's a good example. I'll give you. Here you go. This is hoisting. test is equal to add two numbers. Then we declare add two numbers. So because this is a function declaration, it will move all the way back up here. Right? Oops.
On its own. It used to be that if you had to declare, like I was taught in school, you had to declare your functions first and then call them. There would be an error.
So that's if you're using function expressions. That's if you're using the first way. So, so here's our toast check, and I'll show you down here. If you try to do, it with toast check, right? So if we say var add two numbers, or how about multiply two numbers, a comma b. Ugh, this keyboard is very weird. And then we return a times b. 4 and 5. I don't know. So this is fine. This will cause an error.
Because it doesn't know it yet.
Because it doesn't know what this is
Shouldn't
yet.
it be function multiply two numbers?
Oh, sorry.
Okay.
Yeah. Yep. I'm losing my mind already.
Yep.
There we go.
There you go.
Okay. So if we use a function expression here, we're good. Sorry, we're not good. If we use the declaration, we would be fine. But because an expression treats it like an object, it doesn't know about this object yet. It hasn't gotten there. It doesn't. It's not in the execution cycle. Yeah. But function declaration automatically moves the concept of these functions all the way to the top.
So now they are. It does know it's there then.
So here's a crazy side effect. Oops, actually, let's add two numbers. Let's go in here. All right. Now, because you declared this one first, you would think we're going to do that one.
Right.
But because this is the last declared version of the function, it will do this one instead. Now,
it actually would move it up under the first one,
Yeah.
which makes it the last one.
Yes. So, obviously, that is not intended.
Right.
Now, I mean, this in this case, the function is called add two numbers, so you wouldn't expect a clash or what,
Right.
But if you declared something like save user or refresh page or anything you had in there, and you did it twice by accident, and the second one was slightly different, you might never know that whatever code you wrote first doesn't matter.
Right.
So
what it's doing, it goes through all the code, finds all the functions, and makes them aware.
Effectively,
makes
yes.
the program
It makes
aware.
within that scope, yes. So that's dangerous. There are very good reasons to do it, but we're not going to go over them in this particular tutorial. This is just kind of a bare bones intro.
So the best practice is to use the var.
For now, stick with the expressions.
Expression one. Got it.
So here's an example of a good reason to use the regular declaration. A lot of times people write these like pseudo classes, and I won't go too far into depth in this, but JavaScript isn't fully object oriented. It's because of the way it's designed. It functions a little strangely. So there isn't a class keyword. Usually you create objects based on other objects. So it's as if your first object is a class for the second object.
Okay.
And one of the ways that they do this is that you can create a class function, the equivalent of a class function, that takes in some parameters and effectively becomes the new object. So you'll see I've got two properties. Using this references the thing we're inside of. And I've got an internal function as well. And later on down the page, I can say some dude is equal to a new dude. And he is Mario, and his job is a plumber. And then I can have him say my name. So you can use this pattern in particular to make lots of people with the exact same properties. And that way you know what you're getting. Lori had mentioned earlier, because you can just dynamically assign crap to other things, you don't necessarily know what properties you're going to have. But if you use this pattern, then it's very easy for someone to produce objects that all have the same base elements.
With different values.
Yes.
So it's a class creation function.
Effectively, yeah. As I said, classes don't really exist.
Yeah. Mm-hmm.
It's creating objects that are based on an other object.
That makes sense.
Interesting.
All
I
right.
need to practice that stuff.
It's very cool, but again, we'll get into it in a later thing. So let's stick with function expressions for now. Let's get some stuff done with logic.
Mm-hmm.
There are donuts. True. If there are donuts, go nuts. Basically, you're just checking to see if something is true. You could say on here, oops, true, like that. But because it's already a Boolean, it's already either going to be true or false. And this would evaluate, using the equal sign, evaluates to a Boolean result. So we can just say, if there are donuts, go nuts. If this was, let's say, heck yeah, then this would also evaluate to true, but it might not be
what you're really looking for.
Yeah, because you're just testing to.
You could say heck no, and you don't want it to evaluate
exactly.
true.
Yeah. So you could also, in this case,
you have to compare the string. Yeah.
There you go.
Yeah.
So as long as you know what you're getting, like what type of object you're dealing with,
right,
you know how to produce your logic statements. This, for example, where we just declare donuts.
is a function, right?
Donuts is an object.
Go nuts. Go nuts.
Oh, go nuts
Yes.
is a function. Yes. Go nuts is a function, and you can tell it's a function rather than a variable because I've used parentheses.
Yeah.
So here we go. This is if I declare donuts without any information. This would not happen. Donuts would equate to false because it's either 0, false, null, or undefined. So that is important to know because you will see a lot of people testing to see if an object even exists by using if and the name of the object. All right. Here we go. So we can test if something has been assigned to via the if statement. Again, I was just talking about that. So here I'm testing to see if donuts exists. And the donuts.length is greater than 0. So if I have some donuts, then I'm going to eat a donut. And you'll see this is a function, and I'm passing in our parameter here as donuts. If donuts exists, but it's empty, so if it's just a blank array, then I'm going to sulk. If donuts doesn't even, if the concept of donuts doesn't even exist, if this is never declared,
You're gonna sulk. Yeah.
then I don't even know what a donut is, and I live in a sad world. So those are some basic logic statements. And you notice we've got if, else if, and else. So you can chain those. You can keep doing else if, else if, else if, else if. And there's another way to do that, which is called a switch statement, but we're not going to worry about that just yet. We're going to stick with just if statements for now.
I'm trying to understand this. The reason you use the first else if there. So you're already checking if donuts exists, and if it's less than.
And if its length is greater than 0.
Then it's
So if you took glazed, and chocolate out of that array up there, it would fall into the else if.
But you're already checking that in the beginning, the first if.
Correct.
But it's not going to get into that first if
because it will fail the second.
Right.
Gotcha.
Another way to write it is, oops, let me put these back.
Okay.
Gotcha.
Instead of doing this else if, you could say inside here, if donuts.length is greater than 0, and you could remove it from here, and you could
You're
kind
separating
of
them. Yeah.
Yep. So these are my ego. Oh, it's still down there. I was like, what?
Where's my
You
ego?
left it behind.
Where's my ego? Yeah.
And then your self would be there, yeah.
So those are equivalent, functionally equivalent. But obviously, this is a little
It's easier to read the
weird
other
to
way,
read.
yeah.
It's a little less interesting.
Yeah.
It's a little more verbose.
Mm-hmm.
I won't hold it against you if you do that. But if I'm code reviewing you and you've got like 5 years of JavaScript experience, I will mock you. Okay. Loops. We got on if statements. We feel pretty comfortable about them. Loops. All right. Loops are awesome, and you will see them all over the place. Usually, they involve arrays or some sort of condition of like while something is true, right? So we've got two types of loops. We've got the while loop and the for loop. The while loop will do something over and over and over and over until whatever you told it in parentheses becomes false.
So as soon as x becomes 6, it becomes false.
As soon as it becomes 4. Because this is a greater than.
Oh, greater than,
yep.
Yeah.
Or a 5, actually, because 5 is not greater than 5.
To, right.
So, all we're going to do is we're going to keep saying, still counting down, until, and then, you'll see I use the extended form of this, x equals x minus 1. That's so it's a little bit easier for you guys to read, but you could also say...
Minus equals 1.
Yep. Or you could say minus equals 1, or however you want to do it. These are just shortcuts. So over and over, we'll just keep doing this, subtracting 1, until eventually x becomes 5, and then we break out. Sorry, x is no longer greater than 5, because it is 5.
And then you exit the while loop.
Yep. You can also do things, let's say you want to keep repeating something for forever. Maybe you're tracking mouse movement, right? And while someone's on that page, you always want to track mouse movement. You can do a while true. I would suggest maybe putting that inside of a timer, but in this case, we're just saying while true. You could say while something, and then change the value of something later on. So if we start out with something equals true, and then we're doing this while loop, and maybe we've got some other code that comes in and goes, nope, something is now false. You could do that. But in general, you will see it as a while x is greater than 8 or whatever. For loops work similarly. I mean, it's still a loop, but they involve a little bit more declaration, and you don't need to pre-declare the thing we're checking. So in this case, when we say for y equals 0, semicolon, we're actually creating a new variable right here. We made a brand new variable. It's called y. Then
setting its value, right?
Yep, and then we're going to say while, so this is the while part, same as up here, while y is less than 5, and then we're going to say y plus plus. So effectively we've done this part, then this part, and then this part, all inside these parentheses. This has always bugged me about the language. There are semicolons after the first two. There's not a semicolon after the third one. It's always been that way, and it always bugs me. I don't know why there's no semicolon.
I think it's just to show a separation inside the parens. The parens actually kind of ends it. You know, I don't know.
I mean, sure. I have no clue. I'm sure there's a really good reason for it, but it's always slightly annoying because if you do put a semicolon there, it gets grumpy.
Right.
Anyway, so in this case, we're going to go from 0 to 4 because we're looking for y less than 5. And we're going to add plus plus, and we're just going to alert. So those are the two types of loops you'll be using. You'll probably use them a lot for all kinds of things because it's very rare that you won't encounter arrays or some sort of math thing. Here is an example of an array that we're going to loop over. Balloons. You'll see each of these balloons has a color and whether it's popped or not. Pretty straightforward. This is, again, it's an array because it's got the brackets.
Square,
If you'll notice, it's an array of objects, not an array of primitives. This could be an array of primitives. You could have 5, 6, 7, whatever. But there's no penalty, like there's nothing bad about using arrays on objects. I use them all the time. We're good. So in this case, we're using the same object structure over and over. This is JSON. You could also use that class sort of thing that I mentioned earlier if you wanted to do that. But that's, again, kind of a little later thing. For now, we're just declaring the same thing over and over. We also have a terrifying clown. I hate clowns. This guy is Cuthbert, the Clown of Chaos. And he has a bunch of props that he carries with him. Those props are balloons. We have a function to pop a balloon. We have learned this some point in our life. Presumably, when we're children, we get the pen and pop the balloon, blah, blah. All right. And we have a plan to defeat the clown. So, to defeat the clown, can anyone tell me what this is going to do?
So, I'll go with order because it first checks to make sure that the clown has a prop. Then it tells you, gives a balloon number of 0, creates a variable, and assigns it 0. And while the clown doesn't have a balloon number.
Not
No.
quite.
What balloon number is less than clown prop length?
While
So-
the variable balloon number is less than the number of props, the length of the props that the clown has, you're going to do that while loop.
So
Balloon number.
up here
He
we've
has
got
1,
1, 2, 3, 4, 5, 6. Okay.
So
Six.
for each balloon number
Is less than 6.
is less than 6, it's going to. So basically, for each balloon number, not just but it's counting down, right? It's just removing one for.
Well, so we're starting at 0.
0.
Yep. We're starting at 0. We're starting at balloon number 0.
Okay. So you're waiting for the balloon number. You're waiting for the number of balloons to go down to 0.
Yes. Well,
Right,
we're
so
going
it's
up.
going
Well,
through-
we're going up from 0, right?
You-
So we're
You're
comparing.
waiting until it reaches the number of balloons that the clown has in his props.
Yep, because we've got a number of.
Yeah. So that'll be 6 there.
Yeah. So this would be 6, correct?
So
Yep.
it'll do it while 0 is less than 6.
Right. So to start with, obviously 0 is less than 6.
Yeah. So it'll do it.
So the
It comes
first.
in.
So in this loop, we're going to declare our current balloon. We've got a target balloon. This is the balloon we're going to get.
Yep.
We say clown.props, and then the
Balloon number.
Yep.
So it's
this,
first balloon.
Okay.
Yep. So this is balloon number 0. Remember how I said it's a 0-based
Starts with
array?
0, yeah.
Yep. So our current balloon is the 0th balloon that
Yeah.
the clown has.
Okay. It's going to call the function pop balloon of the current balloon. So
Yep.
it'll go to this pop balloon and mark it as true. So it will now be popped.
So the first balloon is now popped.
Yeah. And then it goes to the next balloon number. Which
Yep,
is balloon
which is
2.
Which would
One.
be what? Oh, okay.
1, which is 1,
Yeah.
yeah. And it's less than 6.
Uh-huh.
So it will go and get the current balloon and
So we'll get the
prop,
first
balloon
number, the balloon number 1.
Yeah, and then it's going to pop the balloon and keep going through and through until it hits the 6th balloon and
So
Well, as long as
Wow,
it's
balloon.
less than 6.
is less than 6.
So when it gets
so
to
when
6,
it gets to 6, what's going to happen in this loop?
it's going to fail.
Yep. So it's going to end the loop.
exit.
It'll come down to alert.
And an alert just means
Your
show
plan
up
succeeded.
in a browser.
Yeah.
Alert will say make a pop-up
Pop-up,
box,
yeah.
basically.
Right.
So basically, this just says let's go through all the balloons one at a time and pop them.
Mm-hmm.
So you'll usually see this because .length is an actual count of the number of things in there,
Mm-hmm.
but it's a 0-based array. You'll usually see a less than sign rather than a less than equals.
Mm-hmm.
Because that would make it 1.
This would go
and make
one
it one
more.
more.
Yeah.
Right.
Yep. So this is our plan to defeat the
Once
clown.
you get an error, something about exceeded the
Yeah, the array indices or
array,
something.
right,
Yeah.
right.
Yep. So if we call plan to defeat clown, oops, I'm not going to pop. We want to say terrifying clown. So if we call plan to defeat clown, we pass in the terrifying clown, we will pop all of Cuthbert the Clown of Chaos's balloons.
Defeat clown, yeah.
Yep. Cool. All right. So we are at 52 minutes. This is a pretty standard. I mean, obviously, this isn't a standard function that you wouldn't make a function like this, but it uses
The
most of the
format
things
kind of
that
thing.
that matter.
That's cool.
Yeah.
Do you have any questions about that?
I
Like, is
think,
there-
I think we should need to practice that to really understand it, you know?
Yeah. So you will use all of these various things a fair amount. You'll use while loops and for loops. You'll use if statements and else statements. You know, if else. Use variable declaration and functions, and obviously you use objects because that's what we do everything to. So that is pretty much the end of what I've got
That's
right
awesome.
now.
Yeah.
I'm gonna give you guys some homework.
Yay!
And I won't give it to you right now. I'm gonna email it to you
Oh,
at the end of the day because I was
When's our
gonna.
next one, Tuesday?
Yep, next
Okay.
Tuesday. But I will try to record this, and I've been recording it. I'll upload it to some kind of internet location, and send it over to you guys. But yeah, that's the basics of JavaScript.
Okay.
You'll see pretty much everything here used on a day-to-day basis. Like if you go to a website and look at the stuff, almost everything here will be used in some manner. Obviously, there are more complicated ways of using these things, but once you have the fundamentals down, you can read most JavaScript and you can pretty much understand what it's doing. So obviously just focus for now on learning how to declare objects and learning how to declare functions and learning how to do things inside of a loop with those objects and functions. So that's it. Objects, functions and loops. Cool.
That's good. It's easy to understand those separate. When you combine them is when it gets...
See, combining it, like I'm used to old JavaScript. So when you started doing the var, a variable name equals function, every time I saw that, I was like, I'm not understanding this. Now I understand it. Yeah.
It is weird that there are two ways of doing it.
Well, basically what I would do was create my function and then just assign it to a variable.
Oh, because fair enough.
Now it makes sense to me that that's all you're doing, you know.
Yeah, effectively that's what you're doing here when you're doing expressions.
Right.
It avoids the side effects of hoisting. But again, hoisting can be useful, right? So if you're one of the things that
because like old JavaScript, we never did the expressions. We always did
the declarations.
The declarations, always.
But the problem comes when you have not the same function twice. It's only using the last one.
Exactly.
Yeah, and that happens sometimes by accident.
Yeah.
You know, like nobody means to do that.
Right.
But
I don't know that I've ever run across that, but yeah, there's a possibility that could have happened if different developers were working on it. You know, yeah.
And you can also use the expression to declare things. I mean, you can use declarations as well, but you can use expressions to declare things inside of other functions. So you can have a function that has its own little mini functions. And we'll go over that later. It's called closure to generate internal functions that have access to that object's stuff, and then to call them later on from a totally different scope. And I'll go over those options. But
Is there a performance hit with using hoisting?
Nope. There's no performance.
I mean, it has to go through and read all it.
I mean, it already has to go through and do that stuff anyway.
Could you not end up with like a var toast check equals a function and another var toast check equals a different function? Like, do you happen to pick the same variable name?
You could totally do that.
But if you use the namespace, you might be better off, right?
Yeah.
Okay.
Or if you're using them inside of objects and things, like so, obviously this guy, where's dude? There might be other objects or things that have a function called say my name, but this is dude.say my name. So it's, that's kind of how it works.
So the way to prevent it up above is to use some sort of
namespacing or objects, things like that.
Okay.
Yeah.
And this is only used inside a function because it's that's the scope that it's in, right?
Exactly. So this function, you can't just come out here and just be like
this
and just say my name. It will not. That means nothing. It's only because you're saying dude.say my name that it has some sort of meaning. So
I need to practice that too.
Yep.
Cool.
All right.
That's very good. Thank you.
No problem.
Very nice, Edmund. Very nice. Very amusing also.
Well,
you made it way less boring than most times people teach stuff like this.